Hello and welcome. You are in the right room if you want to learn more about Elixir and Phoenix. But why would you want to learn more about Elixir and Phoenix? Why is that important? Well, I like to say it has a little, let's say, superpower. And that superpower is called standing on the shoulder of giants, standing on the shoulders of the big Erlang. And why is that interesting or important? Or what is Erlang known for? What is this platform that it runs on good for? So Elixir is to Erlang like Scala is to the JVM, or all those JVM languages are to the JVM. So it's the Beam VM, the platform that Elixir and by extensions Phoenix, the web framework for Elixir, runs on. So Erlang, first of all, is really known for its fault tolerance, for its really high availability of multiple nines. And where does that come from? Erlang was built and envisioned in the 90s to run on telephone switches. And a telephone switch should never be offline, They should always be there. And how does Erlang do this? There is this philosophy of let it crash, which at first sounds like the opposite of it, but let it crash and then recover gracefully, because we all know failures and crashes are going to happen. But Erlang, as a language, has constructs to deal with failure, to restore them to a known good state, and continue to keep the system running in a good state. Another thing that Erlang is highly known for is parallelism, that you can do really many things at once, which right now, or in our current world, is really important. And it does so through the concept of actors, as you might know them, although in Erlang they're called processes. And it's all these little units of executions that in themselves are executed sequentially, but you can run all of them at the same time. And in Erlang, it's very easy to run millions of them at the same time on the same node. And spawning it is very, very cheap, much, much cheaper than spawning a thread, for instance. And they communicate via message passing. They also play into the fault tolerance, because each of those is really a single unit. It has its own memory space and everything else. So if a failure occurs, only one of those 1 million or 2 million processes will fail and crash, and leaving the others, untouched, and they will just keep running. So that is very good. And them having their own memory is also very good, because then, once an actor has finished its job, you can just reclaim all the memory, no more garbage collection for it, because each one has its own memory heap and stack. Another thing that's pretty cool about Erlang, or that illustrates this, is Observer. Observer is this little graphical tool where you can connect to a running Erlang node in the cloud, or even on an embedded device or something if you have an internet connection to it. And you can see this. This is a supervision tree, which is basically your application and how they are connected. And the supervisors are what gives you those the fault tolerance that says, OK, this thing crashed, let me restart it in this state. Or oh, this thing crashed, let's also eliminate all of these others and completely start anew because something went wrong. And here you can look into your system, see them, and there's much more information. It's basically your, let's say, process explorer for the Erlang VM, for the Beam VM. And then you can look where are messages piling up from all those actors and what's happening. So it gives you really good insight into the system for live debugging, basically. Another thing that's very, very well known for is hot code swapping. So basically, when you want to deploy a new version, you basically just apply kind of a patch, and it can be applied immediately. You don't have to shut the VM down or anything and start a new VM. You can apply it to the running VM. So basically, the modules are just switched out with the new version. Sounds incredibly cool, and again, goes back to its roots, because if you wanted to deploy a new version on the phone switches, you just couldn't have all telecommunication in a country be offline for 2 minutes because you wanted to deploy a new version. It sounds a bit cooler than it actually is, though, I must admit, because getting it to work is incredibly hard, because you can imagine if the implementation of a module of the sudden is switched underneath you. That's like having to deal with database migrations, basically on all of your data structures, and being able to handle them gracefully. So usually not super recommended until you really want to have that really zero downtime deployments. Another thing that is really great about Erlang is its capabilities for distribution. Because in Erlang, sort of everything is an actor. And so you can have a node here, and you can have a node here, or multiple nodes, and you can just connect all of them together. And then whenever you send a message to an actor or the process, it doesn't care if it's on your local node or on another node. You won't see the difference. You won't notice the difference. And that is very, very powerful. So for instance, Phoenix, the web framework, is very known for its good handling of channels, so WebSocket connections. And you could have a scenario where you have a WebSocket connection to this node, but now you want to broadcast a message to another channel that is over on this node. But because this is a process and this is a process, it just sends a message to this process and that then broadcasts the message. You don't have to care about it. You don't have to be like, oh, I have multiple nodes. How do I keep all the messages and check that everyone gets them? It just works. And performance, of course, is also often a great concern. So I won't claim that Erlang has like C or Rust level performance or C++ level performance. That's not what we have or what this is. It's pretty consistently faster than like Ruby and Python and the stuff that we think of as slower languages, but can compete with some of the others. And I will show you some examples of companies using Erlang and Elixir in production really soon. However, another thing that's really interesting is performance isn't just how fast you execute code, but it's also how much resources do you consume. And again, it was designed to run on telephone switches in the 90s. So when you ask the late John Armstrong about like, can it run on a Raspberry Pi? It's like, oh, you mean a supercomputer? Because that's what a Raspberry Pi is from the view of the 90s telephone switches. And so you can run it on the smallest embedded devices and things. So it is beautiful, I would say. And last but not least, we have functional programming, which you can like, you cannot like, but can talk about later. But also, since we're here in Malmö, det var skapades I vacker Sverige. So if you're like kind of like a programming patriot in Sweden, all of this was developed by Ericsson in Sweden, and it still runs on like lots of telephone switches, and also Erlang runs a huge part of the internet on like border gateway protocol thingies and switches. So I say all of this, but like, who am I to tell you all of this? Let's hear it from someone else. This quote is from 2008. If somebody came to me and wanted to pay me a lot of money to build a large-scale message handling system that really had to be up all the time, could never afford to go down for years at a time, I would unhesitatingly choose Erlang to build it in. And who said that? Like some super Erlang Elixir hipster? No, was Tim Bray, at the time of this quote, director of web technologies at Sun Microsystems, the people that built Java. So if you don't take it from me, take it from him. And if you still, are skeptical, like, not sure if this Erlang thing is cool, I think we all know what this is. It's the logo of WhatsApp. I guess that probably somewhere around 90% of the people in this room have probably used it. And the service of Erlang, or like their main, I'm very sorry. The main, service, the main communication nodes of Erlang, of WhatsApp, are built in Erlang, and they wrote a blog post in 2012 that they handled 2 million TCP connections on a single node, thanks to Erlang and with Erlang. And so that is, I would say, one of the most massively used messaging application in all of the world, and it runs on Erlang, and it runs very happily so. So, talked a lot about Erlang now. How do we get to Elixir? This nice gentleman is called Joseph Valim. He used to be a Rails core contributor. Just of interest, any Ruby people here? No Ruby people. OK, only Ruby person. Yay. OK. So, and Ruby isn't really great at this parallel programming thing. And so Josie went out and looked for other platforms where parallel programming, where that is easily achievable. And he fell in love with the Erlang VM. There were some parts that he missed from it and that he didn't quite like. So that's when he decided to create Elixir. And it is, as he says in this back in 2016, like my phone has 4 cores. Your phone probably also has 4 cores or something as well. Everything we do should be done in parallel. And that is very apparent in the Elixir ecosystem and like how we do things in Elixir. So for instance, stubbing and mocking is very common in about every language, right? You say like, I take this module and like this function should now return foo instead of bar, I don't know, right? However, what you do there is you create a global state, basically. So now every process, like everything that is executed that wants to call into this also gets this stubbed value, which is why in Elixir we don't use stubbing as much, because we want to run all of our tests in parallel, because we want them to finish fast. There's still ways to do stubbing and mocking, and they're a bit different so that they work in parallel, but that's just the extent to which the parallelism is built into and designed into each and every one of those systems, which is pretty great. So yeah, it's kind of a little marriage of Erlang and Ruby, and you can also see that in the community, which is, I think it's quite great. Now, a good question is, does this performance translate to Elixir? Do we have any performance losses from going from Erlang to Elixir? And we don't. The performance is the same. We compile to Erlang bytecode. Through some optimizations, it can arguably be faster than Erlang, but that's not the main point. This is an experiment that the Phoenix core team ran back in, I think, 2016 or something. I told you before about the WebSocket handling of Phoenix, and they just want to see how many clients can we connect to a single room, to a single chat node, to a single node in a single chat room. Sorry. In Phoenix, and within half a day, they optimized the Phoenix code so much that they could connect 2 million clients to one node in a chat room and have a running WebSocket connection there. And then only topped out at 2 million because they set the handling limit for connections on the operating system level to 2 million because they thought, we're not going to get to 2 million, right? And so you might now think okay, if you have 2 million nodes connected to 2 million clients connected to the same node, resource consumption must be super high there. And this is that node. It's a very beefy node, but you can see there's almost no CPU usage going on, and memory isn't even full yet. It's a beefy node, but it's still not full, and it's pretty much idling. And then you say, okay, connected clients is cool, but what about distributing actually the messages? And story has it that Joseph Lim then took an entire Wikipedia article and pasted it into the chat room, and the message was delivered to all 2 million subscribers within 1 second. So is this just a fringe thing because I'm here on the fringe track that nobody uses? No, of course not. I talked a lot about Erlang, but these are some of the companies, some of them you might know, that use Elixir. We have Bleacher Report, which is a sports news company based in the UK, I believe. They were one of the very early adopters of it. And through adopting it, they went from 150 Ruby on Rails servers to 5 Elixir and Phoenix servers, which they still say is over-provisioned and should probably be just 2 or 3. But they keep them around because, why not? Pinterest, they rewrote their API or parts of the API in Elixir from Java and saw the response times drop to the levels of microseconds, so 500 microseconds or 800 microseconds, and the code involved from about 10,000 lines of code to 1,000 lines of code. Square Enix, the gamers might know, is a games company, and there's also kind of for multiplayer online games, it's a kind of a common use case for Erlang and Elixir to build the account services around, the messaging, the chatting, the login, the authorization, and all of that. That is often, I've seen lots of talks with Erlang people and Elixir people talk about building these systems in Elixir and Erlang, and very, very successfully so. Discord is another chat and voice chat thing in the gaming community that can push all the way to 11 million connected clients to a single node, and they do that all through Elixir and a bit of Rust. The bit of Rust there is they implemented a more optimized data structure to handle this, and that one data structure is in Rust. The rest of it is handled by Elixir and Erlang. So I hope that for all of this, I was able to convince you that Elixir and Phoenix are indeed fast and concurrent. However, through the remainder of this talk, I would like to focus on the explicit bit, because when we often talk about Elixir and Erlang, it gives this impression that you should only use this when you need this highly scalable, distributable, multi-million messages per second or something systems. And I don't believe that it's the case. For me personally, I would rather build a system, even a simple CRUD application in Elixir and Phoenix these days, than I would in Ruby. And performance is not a concern there. It's about the explicitness of the language and the system design that I can achieve with it. So who am I? I am Toby. You can find me on the internet as @Practop. I'm based out of Berlin. I run the Ruby user group there for the past 7 years or whatnot. I am the maintainer and creator of Benchy, which is the best benchmarking library in the Erlang and Elixir ecosystem. I maintain SimpleCoff. I do lots of things. Right now, I started freelancing and consulting, and actually my first project right now is helping a company onboard onto Elixir. So let's talk about Elixir. I know some of you are like, oh my God, please stop talking and just show me code. So here's some code. This is basically the functional programming kind of hello world, we implement the higher order function map operation. We implemented ourselves, and we implemented with recursive function calls. A couple of things to note here. First, it's a bit of Ruby-like syntax. If you've done, okay, you haven't done Ruby before, but if you did, you would realize it looks a bit like Ruby, which some people hate, some people like. I don't think syntax is the most important thing, but there you go. We have first-class function. Of course, it's a functional programming language, so we can pass them around as arguments and whatnot. And we can then also, down here, like call them with whatever we have extracted up there. And now we come to my favorite part of the whole of Elixir and Erlang, which is pattern matching. What you can see here is I have defined the doMap function twice. And you can see in the highlighted second argument differs. And this one basically says that, OK, if we get an empty list, which what this is, as an argument, then execute this function, so which is sort of like the end of our recursion. We've been through all the elements. Then we just return the accumulator. And then down here, what that says is that, OK, we have a list with at least one element. Please put the first element in the list into the variable we'll call head. And the remainder of the list, we'll put it into tail, whether it's empty or not. And that's the way that we split the work and then continue it. And this is really, really powerful. So I want to also show you another use case of pattern matching, which is this. It's our patterns module, and we want to greet people. So let's start greeting people. So at first, we can try to greet Toby, age 30, and we can also pass in something else. What that will do is it will call the greet function, and it will try matching top to bottom if the pattern can be sort of applied to the input. So this says, like, OK, there's a name key, there's an age key, so I'll put the values into the name and the age variable, and then I'll be like, hi there, Toby, what's up at 30? Now I can also match on just a concrete value. So I can say, OK, if I get some map that has a name key and the value in that key is Emily, I can thank Emily for running Øredev for so long. I can just have a name key, then I can thank Tadash. And in the end, if I get something that I don't know what it is, which is just the underscore, which is like I ignore this value, then I can just greet a person. And these are really effectively combinable, and it makes a lot of things much, much easier, especially in testing. So in Elixir, I can write a very concise assertion where I can say, OK, I assert that the return value of this is a list with two elements, the first of which is a map which has an ID key, which has the value 5, and the second of which is a string that says hello or something. And that's all in one line. And it takes a bit of getting used to, but it's very powerful and concise. And it's the feature that I personally, I miss the most in every other programming language. Sometimes I go and write in some language, and I'll write some pattern matching logic, and oh, this language doesn't support pattern matching. OK, let's rewrite this to I don't know, 10 lines of code. Bummer. So back to our initial example. Documentation is very, very big in Elixir. So you have basically documentation built in. So you have this add doc directive, or whatever you want to call it, that is there to really encourage people to do documentation. Whenever you publish a package, it's like, hey, build a documentation and publish the documentation with it. The documentation doesn't only really look really good, but it's also very searchable, and it's very much encouraged in the Elixir ecosystem. So of all the languages I've ever worked with, it has by far the best documentation that I've ever seen. What also contributes to that is that Elixir in its core has built-in doc testing support. Who here knows what doc testing is? OK, some of you. So this is part of the documentation, but it's basically an interactive shell session. And this will be run during my tests. When I run my tests, it will run this code, this map demo map, and it will assert that the output of that is the output that I showed you below, which is fantastic because A, it's an easy way to write tests, and B, it asserts that our documentation never runs sort of out of sync with our actual implementation. So I have a bunch of commits on Elixir itself, and most of it is me adding doc tests and some documentation for some edge case that I wasn't sure about. So then I go there and I document it, and I write a doc test that is in the documentation for the next person after me to come along and be like, oh, how does this edge case behave? They can see it right in there in the documentation and be sure that it still works like this and won't change. So right now I'm just walking you through sort of some of the major features of the Elixir programming language. One big thing that Elixir added that Erlang doesn't have is metaprogramming. So it's kind of like Lispy-like macros, so code that writes code, which makes it really easy to build some fancy DSLs if you so wish, which, for instance, Phoenix makes heavy use of. Another thing that, if you come from an OOP background, you might be worried about, like, oh, I go to functional programming right now. That means I can't have any polymorphism anymore. And that's also not true. You can have something which is called protocols. So we can say here, we define a protocol. It's the blank protocol, which should implement one function, blank. And then we can implement it for all the data types. We can say, OK, a list is blank if it is an empty list, and a map is blank if there's no keys and the values in the map. And we can also define our own data types, and then we can also implement the protocol for our own data types. So you won't lose usage of polymorphism. Another thing that I super love about Elixir is that it's implemented in itself. I come from Ruby. I'm a very bad C programmer, so I could never really contribute, like read the Ruby implementation itself or really contribute to it. But Elixir is all implemented in itself, which makes it really easy to go in there, contribute, or learn, like, how have the actual implementers of the language solved this problem, and then learn from that and apply it to your own problems, which is very powerful. Another small thing that you see here, you've seen so far, Elixir and also Erlang are dynamically typed languages, so there's not many type definitions that you come across. You can optionally add type specs, which are run by a tool which comes with the OTP from, with Erlang OTP, which is called Dialyzer. And so here we say, OK, we have this all function. It gets, something of the type that I've currently here, which is an enumerable, and then it returns a Boolean, or it gets an enumerable, and then a function that maps from one element to a Boolean value and then returns a Boolean value. So if you want that, you can have that. Only thing is, Dialyzer was also, I think, built in, the early 2000s or something, and its error messages are not quite so nice as the ones in Elixir, but it can really help you. And we also have interfaces in Elixir, which are called behaviors. So this is an interface for Plug. Plug is kind of like a HTTP middleware library of Elixir. We'll see a bit more of it later. And here we say, OK, we define two callbacks, which are basically the functions that I have to implement if I want to adhere to this behavior or this interface, which is one time the init function that just sets the initial state that I want to access. And then we have a call function that gets a con, which is basically an HTTP request or the information about that HTTP request and our initial state. And then we return a changed connection because we did something to that connection in the end. And now if I want to, implement this interface, I just say, OK, I follow the plug behavior. Then the compiler will check that I actually implement all of these functions. And then I just implement them. I don't take any state, so that's fine. And then when I get a certain connection, I change from head to get, which is a cool way to implement head. But yeah. So I have kind of left out the function programming bit a bit for now. I showed you some code. We talked about performance. But why should you want to do function programming? Before we get into that, though, I want to talk a bit about what this not is. I'm not some weird guy that goes and points at you to be like, you should all be doing functional programming, otherwise it's bad. Because I've seen these people, and they've kept me away from functional programming. I've been to too many talks where people were like, oh my God, you're doing object-oriented programming. It's aptly named because you should object to it. Ha, 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 ha. It's so bad. And that really was repelling to me because there were these people that were always like, I'm so much smarter than you and you are dumb, and that's OK, why would I want to do your thing if you hate me so much, No, thank you. So think of me more like this. I'm like kind of a nice cuddly bunny that, just wants to share the warmth and the love for something that it has found with you. So what is functional programming? It's really hard to define because there's so many functional programming languages that you can find each and every one of them. For each one, you can find an example that it doesn't fulfill this one property. On a very high level, you could say, OK, it's about where I call a function. In object-oriented programming, I call it on the element itself because we have behavior and state together. But in functional programming, I just call it on the module, and then I pass in the state or the data as the first big argument. That's a bit simple though, but what is true is it's a lot about the separation of state and behavior. In OOP, we took state and behavior and we mixed and mangled it together. And in function programming, we say again, no, like, please, let's keep those two apart. But if it's not about this, what is it about? For me, it's a lot about the transformation of data. So you get some input data, and then through a series of functions, you transform it to the desired output data. That, for me, is kind of the essence of function programming, together with kind of like trying to keep side effects like I/O calls or whatnot out of there, so they have a very pure transformation of data, and then you have these side effects to put them into the database or send them back to the user in the end. So what is this transformation of data? I will argue that a transformation of data is mostly what we do and also applies very, very well to web development, which we'll get to a bit later. So this is like, let's say, normal code. We say, OK, we first find our customers, then we get the orders for our customers, and then we get the sales tax for them, and then we prepare our tax filing. So far, so good. But for me, there's lots of kind of intermediate variables here that really don't help me that much. They kind of obfuscate that all of this is really more like a flow. We first get the customers, then we get the orders for those customers, and then the sales tax, and so on. And this is the, if you maybe heard about Elixir before, this is the famous pipe operator. Don't worry, you don't have to look for a triangle on your keyboard. This is just my coding font. It's like this pipe, it's a pipe, the thingy up, and then like the triangle to the side. My font just makes it all together. Anyhow, and what it does is, exactly as I've been saying, it passes whatever is passed in first. It passes it as the first argument to the next function call, and then the return value of that function call is passed in as the first argument to, for instance, sales tax. So sales tax gets the orders, just as the code we had before. Now, of course, you can't like only do this with a pipe operator, but it's a whole lot nicer. So if you don't have a pipe operator, you would write it somehow like this. And like, who wants to read and understand this code? Because to understand it, you have to first look, where do I begin? Where does this start? What is the initial piece of data that goes in here? And it's all the way back there. And that's the first piece of data. So that's just, in my mind, really, really unreadable, nested, ugly code. So the pipe with this flow of data that really represents that transformation. We start with, customers, and we, turn it into filing of taxes really, really well. Another big thing for most functional programming languages is immutable data. And immutable data, first, like when I first heard about it, it sounded really scary because I was used to, what I do in programming is I would change the state of objects, and that would be, the outcome of what I did. And now I can't change any state anymore. What is this? Why should I want to do this? And it's more like we don't change the state, but we return a new version of it, which we're now going to work with, which through optimized data structures for immutability is not as expensive as you would think most of the times. But I have a question for you. I have a little quiz for you, not as hard as the IQ test from yesterday. But so imagine this is like a mutable language and it's an object-oriented language. So I create a person on the first line and say like, OK, Toby, age 30. Can you tell me with certainty what version of person I'm going to insert into the database in this piece of code? You can't, because in order to really know it with certainty, you would have to look up the do something function and see, does it change the attributes of person under any circumstances? And then you have to look up all the other methods that you hand person to that potentially have the power to change the person. It is almost impossible to tell. I mean, of course you can tell, but you have to look so deep. If you have immutable data, you know that do something can change person because person is an immutable data structure. So when I create a person up there that has name Toby and age 30, when I insert it into the database, it will still be the same person. And that is huge, and really huge for debugging. So, and with immutable data, I would need to make this change explicit. I need to say like, OK, do something, does something to person, and hence I'm going to reassign person. So person has changed here. I clearly communicate there was a changed person here. And you might say like, OK, that sounds kind of cool, but I lose all this power to change all this stuff. But I would argue it's something of, I call it principles versus power. Yes, we restrain ourselves a bit, but what we get from that bit of, that little bit of restraint is a much increased clarity of the code. We also get in functional programming, this really, I don't know, holy grail of testing, same input, same output. Because we don't have any state, there's no state to change the behavior of our functions, which means that it will always be the same. So same input, always same output, which makes it really easy to write tests because you don't have to set up the world around it. What that contributed to for me is that my reading experience of Elixir code is much, much better than any other non-functional programming language. I started doing Elixir in 2015. And I was back then, and probably still am, a better Ruby programmer than I am an Elixir programmer. Still, reading third-party libraries for me in Elixir is much, much easier than in Ruby, because when you go into code of a typical OOP code base, or most of them, you look, OK, what does this do? It's like, OK, this behavior depends on this instance variable. OK, what are all the places that this instance variable can change? And you look at all of those places, and oh, they rely on the state of this other object, where all the places where the the state of this object can change. And it sort of turns out to be this huge web of state that can potentially change, and like figuring out why that state for you at that particular point in time is bad can be really rough. If you have immutable data structures, something like that can't occur. It's always kind of a nice flow, a story that's like, OK, this thing changes here, then this is applied, and this is applied. It is much, much easier to follow. So really early in my Elixir career, and I already read quite some code in my Ruby times of other libraries, I read much more library code because it was much, much easier for me. And again, one word is much, much faster. Another really nice effect of all of this is it makes refactoring much easier. So you have some behavior here, and then all of a sudden, like, oh, I want to have that behavior over there. It's like, OK, let's just extract this and put it into a common thing so we both can call to it. Cool. And then like, oh, no, this depends on like this particular piece of behavior of this thing. So now we're also going to extract this behavior over here. Oh, but these other things, so we can't really, the state, if it moves over there, these other functions also have to move over there. But I don't need these other functions over there. It's like, if you don't have state, you just copy the function, you paste it into a new module, you adjust the call side to the new module, and you're done. It is so easy. Just extracting methods into a common module or something is the easiest thing ever. No hassle. And yeah, as I said before, testing also gets much, much easier. So enough about Elixir. I also still want to show you a bit of the Phoenix web framework for Elixir. And this is basically the transformation that we all do in web development. We get a connection, we get a request, it goes through the router, it ends up in a particular controller, in a particular controller action. We go to the model, we retrieve data from the model, and then we render a view. It is essentially a functional transformation. We get some URL or some request with some arguments, and we transform it into an HTML or a JSON response or whatnot. It's just a transformation, which for me was really mind-blowing first time I read this. So what does this look like? This is a router. If you've ever seen like a Rails-like framework, it looks pretty similar. So we have like our GET request that goes to page controller index, and we have our RESTful resource routes for users. And then, for instance, we can have a look at the show action. You can see there's a bit of pattern matching going on there. The second argument there, like the first argument, gets the connection, and the second argument gets the parameters that were passed in here or extracted from the URL, which in that case is the ID, because I want to show a single user. I get their ID. And then we call into a context, which is a thing that Phoenix introduced with about, I think, Phoenix 1.3. Which is basically normally these MVC web frameworks, or a lot of them are just like, OK, we have model views and controllers. And in there, it's the Wild West. And contexts take you a bit more into the domain-driven design direction of, you have your domain. Maybe, you can sort of sort it into certain buckets of domains or contexts. And then, we don't talk to the models directly, but we sort of talk to our vision into that domain and that context, which is the context. And so quick look at the context. It's very easy because it's a very easy application that I show you as a demo application. And that is just, OK, get user is implemented as we use Actor, which is our database tool, to get the user by that ID. No magic. What is the model, or let's say we call it the schema in Actor? And that's just a mapping onto basically your database structure. We say, OK, we have an age and a name, and we have many blog posts. Why do we reiterate all of these? because in certain contexts, you might not always want to have all the columns of the database. So for instance, most user tables have like an encrypted password hash, like a remember me token and whatnot. But you only really need those in the context of like registration and login. But you will still always load them from the database and have them available everywhere. And you don't need that. So in Ecto, you can define multiple user schemas for multiple different contexts. So you can say, for instance, I don't know, in my blogging context, I only care about the name, the email, and the biography, and then all the other stuff that you have on there, you can just leave out. So all of this then goes back to the show action, and then we go into the view. The view is not as you would usually imagine it. The view is more view helper functions, but it also gets access to, so the templates get compiled to actual functions, which are then callable from the view. And this is what, by standard, a template looks in Phoenix, which is just, HTML with some embedded Elixir. Fairly normal. You can also have other rendering engines, of course. So for the most part, except for context and explicitness, this is fairly like a standard, Railsy web framework, like also Symfony or Grails or whatnot. But what are some of the things that are different? So one of my favorite different things are change sets. Most of these sort of normal MVC frameworks, you have all the validations and all the callbacks and whatnot, they're all put into one model. There's one user model, and it has 50 validations, 20 callbacks. And it's like, oh God, I just want to change one thing, and then you have to work around them with like ifs and unlesses and whatnot. In Ecto, like the database tool of Elixir, it's like, okay, we define a change set, and this change set tells me like, okay, I have these parameters, and of these parameters you can use name and username, and then I have some constraint and some validation specific to the attributes that I just changed. And then it's like, no, but now I want to do a new thing. I want to have some with password. And now I can compose these, so I can say, okay, my registration change set is just like the new change set. However, now I also allow you to change the password, but I only allow it when I say, okay, we're in the user, in the registration change set now, and then I have a bunch of code that's related to the password. So I can build a custom change set for really each custom change operation that I want to make, which makes things much, much simpler because you don't have to tumble over yourself trying to get all of those validations and stuff out. Another thing that's different, as opposed to a lot of frameworks that I see, is it always says like, okay, we want to do the web part and that. We're really good at that. But like, otherwise, please use the right tool for the job. So for instance, lots of web frameworks implement some kind of uniqueness validations. And uniqueness validations are inherently bad, I would say, because they're always prone to race conditions. So instead, what Elixir and Phoenix say, or Ecto in that case, is like, hey, you should implement a unique index in the database. And in Postgres or MySQL, whatever you want to do. And then we're just going to make sure that if that returns an error, we return it into a nice error that is readable, because that is the right way to do things, not uniqueness validations. Also said, like, we won't build our own internationalization tool. We're just going to use GNU getText, because that's already there, it's stable, and it works. Also says, like, we're not going to build our own asset pipeline. We use Webpack as a default, but just one line of configuration that you need to change, and then you can use Parcel or whatever other, JavaScript or whatever other asset management tool you want to have. And that is great, because then I can get the asset management from the people, the JavaScript people that actually know about this, and not some weird thing in Ruby and Rails. But that's another story. I have one more little tidbit for you that is quite new. This is Flappy Bird. Wait a second. And this is implemented in Phoenix. Wait a second. How far can I get? In one of my trial runs, I made one of my best records. So why do I play Flappy Bird? Wait a second. OK. So why am I showing you this? It's like this is clearly client-side code, right? Wait a second. This is still not right. Wait a second. Which is my? I think this. Yes, that's the right slide. So this is clearly client-side code, right? No. All that you've seen right now was rendered on the server side, on a free Heroku dyno somewhere in the US through my conference Wi-Fi. So there's no piece of JavaScript code written by hand that happened here. And what is happening instead, Phoenix uses it, so this is called Live View. Phoenix uses its channels, the WebSocket implementation, to keep the state basically on the server side. So you can think of it as a bit of server-side
react. So it keeps the state on the server side, triggers a new event, renders the new HTML on the server side, and then only sends over the data that has changed, only the data, not the HTML. With that, it achieves very good data efficiency, better than handwritten JSON, because it only sends like an array of all the values that have changed basically over to the client side, and then the client side implements that. So this is what the most important part of that implementation looks like. If we get a key down, we get the game from the socket, and then we apply the flap action to the game and assign that new thing to the socket. And sort of every 50 milliseconds, it sends itself a tick message, which then just updates the game state and then updates it on the server side, pushes it to the client side. And on the view side, it is just like this. It's like typical HTML with embedded Elixir. It's not the nicest, you can see that here it takes the game state and then does some inline styling with the X and Y axis, but it still updates it all on the server side. As you could see, I could play it. I'm not very good at playing Flappy Bird, I promise you this much. Of course, this doesn't mean we should write everything with Phoenix Live View now. And Flappy Bird certainly isn't the best example. It should have been probably implemented client-side, but it's an example to show how well this functionality works, how far you can take it. It's a good use case for you have a mostly static application, and now maybe you want to add a type, a search as you type feature, or auto suggestions or something, and you can just easily do that in Live View without adding on top a whole JavaScript stack if you don't need it, or if you want to have an endless scrolling of people, endless scrolling of a list. So there's so many possibilities there where it fits really nicely in. I mean, of course, the downside is you always need to have an active internet connection, otherwise nothing will work. So if like offline capabilities or something is important to you, then of course it's not something you want to do, but it's pretty powerful and pretty cool. Yeah, demo we already did. So should you all go and do Elixir and Phoenix though? I hope I have at least convinced some of you to give it a try, that it's something interesting to look at that you want to do. If you're from Malmö, there's an Elixir user group here in Malmö that you can go to with good people that you can visit. One thing that I want to mention, just out of openness, I talked about all the great things that Erlang gives us, which are great, but Erlang is sometimes also a bit clunky. So there's some, let's say, a bit old craft when you call, especially into Erlang. So calling into Erlang is super easy, but sometimes Elixir gives you these really nice error messages, and then Erlang it's like, okay, format that string. It's just like argument error. You gave me the wrong format. So it's like, okay, cool. Could you give me a bit more information? And that's not really helpful. And some other things that are sometimes a bit odd, but it's not really that hard, and you can get over it really easily. On the other hand, I hope I could show you that this is a very exciting land, like very exciting possibilities. For me, I always wanted to get into Erlang because I love the actor model. I think it's the easiest model for parallel programming that there is. It's really, for me, it's super easy to understand. Things are executed sequentially. I have many of them. They send messages. Done. It's really easy, much better than like logs and whatnot. And Elixir gives you a very easy and nice way into that. And especially the Phoenix web framework helps you be very, very productive. I love the design of actor, of change sets, and everything else that I've shown you today. I will be around until tomorrow, so if you want to ask me questions, I think I'm a bit over time, so I don't have time for questions now. I'm super happy to talk to people about anything, be it Elixir, Phoenix, or being how much more important soft skills are and all of these things. But anyhow, I'm Toby. Thank you very much.